Hello there, Mr. Sutton here with the Algebra 2 Honors 5-4 Part 2 homework solutions on solving equations with rational exponents and radical inequalities. On this one, we are trying to solve this equation that has this x to the 3/4. Let's begin by trying to get this x to the 3/4 all by itself. So to do that, I can add 14 to the other side. That's 54. And then divide by 2. So we've got a 27 over there. And now to get rid of the 3/4 power, I'm going to use the reciprocal power, which is 4/3. So I'll raise both sides to the 4/3 power. That gives me x to the first on the left side and 27 to the 4/3 on the right. Now at this point I'm going to turn this into a radical so that it's a little bit easier to work with. This is really the cube root of 27 raised to the 4th power. The cube root of 27 is 3, and 3 to the 4th is 81. So this is my potential answer, but I need to plug this back in and make sure it actually works. So let me do 2 times 81 to the 3/4 minus 14 equals 40 and see if that actually comes out the same. So I can rewrite this exponent now as the 4th root of 81 to the 3rd power. The 4th root of 81 is going to be 3. 3 cubed is 27. And then 27 times 2 gives me a 54 for that first term. And then 54 minus 14 is 40. So that means that 81 is our answer. On this one we have x plus 6 to the 1/2 power equals x. Since I've already got this exponential piece isolated, I'm just going to raise both sides to the reciprocal power to get rid of that fractional exponent. So if 1/2 is the original, that means that 2 over 1 is the power I want to raise both sides to. So basically I'm going to square both sides. So that gives me x plus 6 on the left side and x squared on the right side. All right, well this is just a quadratic. Let me zero this out and see if I can factor it. So if I rewrite this, I'll have x squared minus x minus 6 equals 0. And then I'm looking for things that multiply to -6 and add up to -1. 1 and 6 doesn't work. 2 and 3 works if I have positive 2 and negative 3. So x plus 2 and x minus 3 equals 0. And now setting each of these equal to 0 and solving, we have x equals -2 and positive 3. Let's plug both of these into the original and just make sure that this all works out. So I've got -2. I'll plug that one in first. So this is -2 plus 6, which is 4. And then the 1/2 power is really the square root. So we're really doing the square root of 4. The square root of 4 is 2, which does not equal the -2 that we plugged in over on the other side. Since these don't equal each other, that means that -2 is actually an extraneous solution, and we're going to eliminate that. Let's move on to x equals 3 now and hope for better things. So if we plug 3 in, we've got 3 plus 6 to the 1/2 equaling maybe 3, hopefully. This is going to be 9 in here, and we're taking the square root of that. The square root of 9 is 3. Since 3 equals 3, that means that this answer of 3 is the correct answer. For this problem, they're telling us that the maximum speed of a trapeze artist is represented by this v equals radical 2gh equation down here. G is the acceleration due to gravity. It's actually a constant, 9.8 meters per second squared. The h in here is the height of the swing path, and they want us to find h if a performer has a maximum speed of 7. So we have to plug things in for v and g, and that will allow us to solve for h. So for v, that's this 7 here, the speed or velocity. Those are slightly different things, but for this problem, we'll consider them to be the same thing. And then we've got radical 2 times 9.8 times h. So in order to solve for h, eventually we're going to have to get rid of this square root. We might as well just square both sides of the equation right now. So that'll give us 49 on the left. And on the right side, we're going to have 2.9 or 2 times 9.8, which is 17.6. And we also have an h in there, or 19.6, I should say. So now we just have to divide both sides by 19.6. So 49 divided by 19.6 comes out to, well, how about that? Exactly 2.5. So 2.5 meters is the swing path for this trapeze artist. Now, just to be on the safe side, because this is a radical equation, I don't really doubt this answer, but let me just check it to be sure. So let's plug in 7 for V, 9.8 again for G, and then 2.5 for H. And let's see, we've got, I'll just do this in an opposite order, a different order than I did the original here. Let me do 2 times 2.5 first. That's 5. 5 times 9.8, let's see, 0.8 times 5 is 4. 5 times 9 is 45, so that's 49 as a grand total in there. And we know that the square root of 49 is 7, so we're all set. 2.5 is good. To solve this inequality, we're going to first basically treat this like an equation and get x, and then we'll throw in some other considerations as well. Now, the only time we have to reverse the inequality is if we multiply or divide by a negative. So as long as we're not doing that, we're going to keep this as a less than sign. So first step to isolating the radical, we're going to subtract 1. And then we're going to want to divide both sides by 7. So that'll be 8 over 7. And then we have to square both sides to get rid of the square root. So we have x less than, this will be 64 over 49. Now there is one other consideration. Since this is an even root, the radicand in here needs to be non-negative. We don't want whatever we plug in here to be a negative number. So that means that x has to be greater than or equal to 0. It could still be 0, that's okay, but it can't be less than 0. So that gives us two inequalities to kind of put together. X has to be between 0 and 64 over 49. So we're going to write 0 less than or equal to x less than, just strictly less than, because that's what we started with, 64 over 49. To solve this one, let's basically solve for x, and unless we multiply or divide by a negative, keep the inequality in the same direction. So first step would be dividing by this 4 to get that radical isolated. That'll give us a 2 over on the right side. And then to get rid of the cube root, I have to cube both sides. So that gives me x plus 7 greater than or equal to 2 cubed, or 8. And then we'll subtract 7. That's pretty easy. So we have x greater than or equal to 1. Since this is an odd root, we don't have to worry about the radicand being negative, so we can just leave this answer as is.